Can you tell us a little bit about the photovoltaic system here?
Yeah, sure. It's interesting, what you're looking at here is about 140 kilowatts of PV that was installed when the building was first erected. And they're actually polycrystalline PVs which were installed, and in those days they were quite expensive. And it's interesting to see that they're all located on the angle of the roof, and the roof was specifically designed at this precise angles to take care of, or to be able to take advantage of the sun at certain angles during the year. So even at winter time, when the sun's low in the horizon, it's able to provide fairly high efficiencies to the PVs. And in summertime, at the same the ones which the PVs which have a flatter angle can also provide very good output. It's interesting, actually. A lot of questions are asked about the cleaning of the PV cells. Because of the angle, there's a reliance pretty much on the rain to clean a lot of the dust off when the rains occur. Over in the corner over there as well, there are some solar thermal installations which allows hot water to be generated directly from the sun, and that's used for the domestic hot water. And one of the very innovative early examples of glass or PV systems installed within a glass is actually down here as well on the atrium glazing, and you can see down there the polycrystalline cells which are actually installed within the glass, and that can be seen from not only the top here but also from underneath from the atrium.
So the output of solar PV is DC, but AC is used in the building. How is it converted from DC to AC?
Well, it's interesting actually, Angela, because what happens is these PV arrays are installed in strings, and they're all connected to provide a voltage, a DC voltage, and that DC voltage in amps and power is then connected to the inverters, and those inverters are located along here, and you can see a couple down through here, and then there's also a few in the plant room as well. And those inverters actually change the TC voltage into an alternating current, and then that can be synchronized then with the power coming in from the mains.
How is shading avoided with the PV panels?
Well, shading is a very important part, because if any of the PV panels on one string are shaded, it can affect the output of all the PV panels in that string. So what's happened here is that the design has been designed so that the inverter and the string of PV panels are actually on one face, with very little shading impact onto any of the PV panels in that string. So as you can see here, each of the different layers of the atrium on the building roof don't shade at any time, whether it be summer or winter, the PV panels behind it.
Is it important to have PV panels on an angle?
Not so much in this day and age. When this installation was built, PV panels were very expensive, and so you wanted to get every little ounce or kilowatt, should I say, of electricity out of them when they're actually installed, to provide a better payback on the installation cost. Whereas today, because PV panels are so cost-effective, or so cheap, let's say, what you find is that a lot of developers are installing them just flat on the roof, and the losses that they make because of the angle away from the normal to the sun is offset by providing just a few more PV panels, because it's cheaper to put more PV panels on than it is to install an angled roof or a support frame.